Well, hello Cinemeric Nation, and welcome to Simply Cinemeric Live. I'm your host, Chris Pollack, and today we're going to be discussing the digital twin. But before I get started, let me just let you know that there's a Q&A or a chat window there. So any questions that come up during the event, please feel free to type them in. My colleague Lars Fowler is online here, and he'll be typing back to you, hopefully answering any of your questions. Certainly, if you have any specific questions for me after the event, just reach out directly to me. I'd be happy to talk to you. So without further ado, let's start talking about the digital twin. So what do I mean when I say the digital twin? You know, we hear that term used a lot in all kinds of industries. Well, simply from our side, it is basically a virtual representation of my physical machine tool. So why do we need a digital twin? What is this doing for me in my business? Well, this really kind of answers a little bit broader picture, and it kind of goes into this entire digitalization or Industry 4.0 topic. So what you're trying to do when you look at your day-to-day processes, it was trying to figure out how can I make my capital equipment or my processes within my business more proficient and basically reduce my downtime or increase my uptime to my machine tools to make them more effective. And that is what we're trying to do here with the functionality of a digital twin. We're giving you a tool that allows you to start to look at the processes you're doing in a physical world and see what of those processes can we maybe offload over to the virtual world, which at the end of the day, the whole intention is keeping this spindle running. Because if my spindle's running, I'm making money. If the spindle's not running, I'm not making money. So when I look at this machine tool, there's really two factors that is going to reduce my productivity. One certainly would be machine downtime that would cause by maintenance issues, machine breakage. That is not something we're looking at today. What we're looking at is the second scenario, which is really when I look at setting up new jobs. Right? The minute I transition from one job to another, I have pretty significant downtime. Now, there's a lot of processes you do during the setup that you certainly wouldn't be able to reproduce virtually. Yes, you're going to break down tooling, mount tooling up, mount physical vices, edge find or indicate. Those are things you're going to have to do at the physical machine tool. However, there's a lot of processes that you can start to look at virtually way before you get down the machine. How does my work holding nest on my table? What do my cycle times look like? Am I running into any problems from the part program? And the last thing I would want to do is have to do those things in front of that machine, because now I'm keeping it from running. So let us explore the digital twin. Now, what we're going to look at here is we're going to look at a piece of software we call Sinutrain. So in our case, this is our digital twin. Now, a lot of us might be used to Sinutrain and think of it as a simple training tool. But it's not really a training tool. I know it says it in its name, but what its real intention is it's a CNC control emulator. It's designed to do everything I can do at my real machine tool control in a virtual environment. However, there could be a disconnect here, depending on the configuration of the machine I pick. And this is where we get into the whole digital twin concept. So the machine you're looking at there in front of you on the right side of your screen, that is a duplicate of this machine that was built from a file, an archive file that was pulled out of my machine tool and imported into Sinutrain. So what that's doing is it's bringing over all of the machine parameters, everything that this machine knows and is exactly set up for at the moment in time when that file was created will now get duplicated over in Sinutrain. At that point, we've now started to create a digital twin, but we've taken it to the next step. So by bringing over the parameters, I can start to look at functionality that I would normally have to do it on the machine tool, but I need to be able to spatially understand what's going on in my machine. So bringing it to the next level, what we've done was we've incorporated a machine space model that was built from physical files, physical STL files that came from the OEM's machine. So when this machine was designed and built by the manufacturer, in my case Fryer, these were the files that were used to design and build this machine. Now once I bring those files in and I position them in exactly the same locations in space is the real machine. So everything is datum from the true machine 0. Now I can really start to reproduce steps that I would normally be doing out at the machine tool. So how accurate is it? What does this really look like? Well, here on my machine, we see I got a Kurt vise, right? Dropped on my table, sitting in space. Well, the position of that vise was actually located based on the position of the vise in my machine tool. So if we go to our work coordinate system, we take a look at G54, I have it up on the screen of the machine tool. I use the upper left-hand corner of the vise to set my 0. So I just came down with my probe, measured this corner, found the 0 after I obviously trued up my vise and bolted it down in place. So once I had the numbers here, if I did my job properly when I built this digital twin, well, I could immediately plug the exact same numbers over onto this side and then use these numbers when I positioned in my vise, my work holding, into the space of this model. Now it gets dropped in through our kinematic tree here. So I go to my vise. If I look at my vise and I look at the offset driving the vise, all I had to do was set the 0, and I did that in a CAD system prior to exporting this file. I set my 0 at the upper corner of this vise where I'm setting it in the real world. I used the same exact offsets, and now I was able to spatially drop that vise in the exact same place as I would have had I done it in the real world. And in fact, I did do it in the real world because you guys are looking at it there. So what does that do for, let me just close that element. Okay. So what does that do? How can I kind of validate where it is? Well, let's take a look. So here I have a little program where I'm going to grab a probe and I'm going to position it at the corner of that vise. So if I look at it virtually, and we're going to bring up our machine space model so we can see, we're going to have the machine come down, position, there's my probe, and you see right there, it's right at my corner. So do we think I can get there with the machine? Well, boy, I hope so. So here we're going to jump over, get into our program. I've built the exact same program here on my machine tool, doing the same move. We're going to load up our probe, and now I'm going to position down to the corner of my vise. So to give you guys the close-up view, and certainly it's hard to see, I'm sure, but we are right there at the corner of my vise. So validating that my spatial representation of this machine tool is the same between my physical realm and my virtual world. Okay, so from there, it starts to open up a lot of possibilities that we can do with our machine tool. So I can start to reproduce different setups, I can do some analysis. So what I want to do first and foremost is just to kind of drill the point home. I want to get this machine running. So let's just pretend, and I'm not going to have it cut chips so it's not too loud. Let's just pretend, for argument's sake, this machine is working on some job, kind of cranking away while I'm working in my office getting ready for the next job. So that is what we're going to do right now. Okay, we're going to let her run, and we are going to go take a look at our digital twin and what is possible with the digital twin. Okay, so this is my Sinutrain machine. If you don't mind, I am going to grab a chair because I'm going to be sitting down here for a little while, and it'll be easier than bending over. My back is not what it used to be, that is for sure. Okay, so first thing you look at this and think, okay, well, all right, I have a spatial model of my machine. Certainly I could do some programming at the control, but I could do it at my PC, or I could go in and write a shop mill program or a G-code program. Yes, you can do all that. What if you have a CAM system? What if I'm using this CAM system to methodize some job? Well, having Sinutrain as a piece of your CAD/CAM process train actually is a very critical step in evaluating what's going to happen on the shop floor when I actually get down there. Now, you might say to me, well, Chris, I have some great simulation in my CAD system. I can come in, I can bring up a machine space model, I can start to take a look at my entire working environment. And in fact, I did that very thing. This is my machine, right? They've built it from the same models. I can see the housing, I can see my tool changer. So why do I need that back there? Well, this is a great tool while I'm first coming in, taking a look at work holding, maybe collision checking between holders and my fixtures and my part. And we are not trying to dismiss the validity of this type of function. However, there are things that this package does not know that my Sinutrain knows. For one, it might have some overall travel set in it, but it has no idea how that machine was optimized. It has no idea what its acceleration, deceleration. In fact, if I don't tell it, it wouldn't even know what the rapids of the machine physically are. Additionally, when I build it, it's not built off the machine zero that my physical machine is built off of. It's actually built off of a point in the center of its travel. And you'll find that with a lot of simulation engines. They're working off their own specific point. What we're doing in Sinutrain is we're actually working off the true machine zero. But this is where things get really kind of apparent. So let's take a look at this part. Now, if you look at our cycle time here, this part took 4 minutes, 18.96, so just about 4 minutes, 19 seconds to run. And I would see that whether I'm doing the spatial simulation here with machine space, or maybe I'm just coming in and doing a back plot here. Either way, we're going to start to see, and we can run our back plot. We look at our cycle time. There's our 4 minutes and 19 second cycle time. So the question is, well, what would happen in the real world? So now I'm going to take my toolpath, I'm going to post it out, and I'm posting it to a shared folder that I'm sharing between my machine, my Sinutrain control, and my CAM system. So we're going to drop that in. We'll post it out, and we'll see that we're running a G-code file. Pretty straightforward, nothing too fancy here, no kind of fancy technology cycles, just basic rapids and feeds, right? So let's see what happens when I come over to my digital twin. So I want to go to my shared folder. Now I like to post into a shared folder. You don't have to. I mean, I could be running right from that program folder, but I like to move my programs into my NC memory. What that allows is if I'm coming in, if I left it open, or I'm doing any manipulation of my file here, and then I jump out to Mastercam, let's say, and I repost, if I left the file open in Sinutrain, it's gonna tell me it can't write to that file because another program's using it. As long as I kind of keep the two separated, then I can bounce in and out of them as much as I want. So we can come in to simulation. Specifically, I'm in auto mode, and I want to launch my machine space model that's found under my further views and my machines. This way I can see my full range of motion that my machine is going to undergo, and now I can start to look at the toolpath. Now, it's important that when I run this, I'm running it at 100% specifically for my feed rate override, because my feed rate override is going to directly affect my cycle times. And certainly if I slow things down here, then that's going to affect the overall cycle time. So I'm looking at an exact kind of one-to-one scenario between the two, between my CAM system backplot or my third-party simulation and my simulation over here in my machine space model. So we finished running. It's probably got about one more pass after this. So now she's coming down to the final pass. And I can start to see my cycle time here. And I can notice that I just exceeded my 4 minutes and 19 seconds. I exceeded it because at the end of the day, right, we are evaluating the full tuning profile of this machine tool here inside of our digital twin, because we know everything about that machine. So if I go over and I look at my cycle time, I now have a 5 minutes and 5 second cycle time, as opposed to my original cycle time over in my CAM system of 14.9. Now, what I didn't tell you is the actual part program we were running on the physical machine is that toolpath. So if I come over and I take a look at my cycle time, right here, you'll notice it's 5 minutes, 9 seconds. Well, that's a lot closer, certainly, than I was just seeing before. So that's where my digital twin and my physical machine tool start to get kind of parallel right up. Now, why is there a little bit of a discrepancy? Well, in this case, I did a tool change from my probe to my end mill. That's one of the things that Sinutrain is not going to be able to estimate. It doesn't know how far the carousel is spinning. Certainly you could add a factor there. You do want to be careful though, because obviously if the carousel's got a clock 180 degrees, it's going to take longer than if my tools are one pocket off. So that's where you'll see a few seconds, but certainly a lot closer than a 4 minute 19 second cycle time to a 5 minute and 9 second cycle time. So from there, as we expand on, and I'm going to e-stop the machine so it gets a little quieter in here, I can start to explore this even further. So if you start to look at some other tool paths, all right, let's say I looked at more of a tricoidal style tool path, right? Well, once I get to a scenario where not only is the cycle time or the tool path cycle time getting longer, am I going to see that differentiator between the estimated cycle time and the real expand. But wherever I get scenarios where I have a lot of axis reversal, it really becomes apparent. So in a tricoidal kind of tool path, as we come down, you see there's a lot of back cuts. Let's get past the lead in. And this is very typical in tricoidal. So whenever you're reversing direction, whenever you're going and switching to another axis, that's when the axis optimization and the machine optimization really comes into play. So to show you here, and one other example, so this is a 9 minute and 29, we'll call it 9 minute and 30 second cycle time that the back plot or machine simulation would calculate. So if we come over to our Sinutrain, now I already posted that one out as example 2. We're not using any kind of technology cycles here, so just straight feed rate. I come into auto mode. Let me go back. I had left the overstore active. Back out of here, reset. Okay. So back into the part program, execute. Now, when I'm doing cycle time analysis, I don't have to watch the full machine space model. Certainly it's nice to watch the picture flying around, but if I just want to get it running, fire it up, and go start to do some other things, I certainly could do that, start to take a look at another operation, and then we could bounce back in. The big key is you want to run this in the auto mode. We do have simulation in the editor. However, that doesn't take into account all of the machine parameters. So when I'm looking at a true cycle time one-to-one that I would expect to see out on my floor, I do want to do it in the auto mode. So we run this, come up with we're about 6 minutes in, and when we get to it, we can do a comparison. So we were at, boy, I forget, let me just double check. What's nice with the back plot in Mastercam, for argument's sake, you don't actually have to run the back plot. It comes up immediately. So 9 minutes, oh, it's 34. I wasn't taking into account the rapids. Okay, so 9 minutes, 34 seconds. We come over here, we see, okay, we've already exceeded that, and it's just climbing. Now, certainly when we're looking at the machine optimization, machine tuning profile, it has a big variance. But there's also a little more going on here that becomes really apparent when I'm trying to validate what my tool paths are going to do on the floor before I get down there. And really it becomes visible when I start to look at what we call technology cycles. So what do I mean by technology cycles? Well, certainly it could be something as simple as a drilling cycle, that's a technology cycle, or maybe something as advanced as a high-speed cycle. So whenever you have a cycle that the control is making decisions on the motion profile based on the cycle, if I'm drilling, I'm moving through the drill, you know, all the CAM system's doing is passing a cycle to it, cycle 81, 82. The decisions of the motion are really handled in the control. Same thing with functions like high speed. Well, whenever you get a cycle like that, the simulation engines, these third-party simulation engines, they have to make a guess, right? They have to make some assumptions as to how that tool path is going to run. Well, if any of you have ever been debugging a post and You simulated a drilling tool path, you walked it down on your floor, and then all of a sudden you get down there and it's got all kinds of problems. It's lit up with errors, or maybe just won't run, and you realize, oh, it's a post problem. Well, that's a perfect example of where the third-party simulation engine, it doesn't know how the control is really going to interpret something. So what we've done here, and in this case we're going to use a roughing cycle as a demonstration, is this Sinutrain not only knows all the machine parameters, but it actually has the same brain as my machine tool, as what we refer to as the machine's kernel, or our NC kernel. And in the virtual realm, guess what we call it? VNCK, our virtual NC kernel. So that NC kernel is physically running in Sinutrain, and that is a kernel that was designed by Siemens and developed by Siemens and then implemented in our CNC controls and in our software. So once that kernel comes in play, now I can start to take a look at different technologies. Now, if I had backplot with cycle 832 on or off, no matter what I do there, I'm always going to end up with the exact same cycle time. Because the CAM system, the third-party simulation, it has no idea what the control is going to do with that cycle. However, I come here, we're going to grab our toolpath, we're going to drop it in. If I open it up, this came right out of my CAM system. Just show you real fast. Oops. There's our, I love groups, I use groups all the time. There's our cycle, our roughing cycle. So now we drop it in and rerun it on the machine tool. And certainly we can bring up the simulation, because who doesn't like a cool picture coming? And we're validating our work holding, but more importantly, I can start to look at my cycle time. Now, I don't know if you guys can see it through the feed, but even when I look at the motion, once I start to add cycles like 832, I can see a much smoother motion. So what cycle 832 is doing is it's really taking the linearized toolpath, and it's then interpolating or extrapolating a spline through those points. I look at my cycle time, boom. Now I'm down to 4 minutes and 26 seconds as opposed to my 4 minutes and 19. So what happens is when I leverage something like a high-speed function, my gap is going to shorten. But more importantly now, I can see the benefits or the effect of cycle 832 here in my PC before I get down on the floor. Now, not only can I look at it from a cycle time perspective, but we can also start to look at it if I get into like free-formed 3D type of surfaces. So let's say I was doing a geometry like this, right? So we're machining some surface, and not only am I concerned about my cycle times, but potentially what my final surface finish is going to look like. So here I was just looking at a semi-roughing or semi-finishing toolpath, either way you want to look at it. So first thing we did was we did some basic planar roughing, and then this is going to be the first toolpath coming across the surface, certainly leaving some material for a finish cut. So I may want to see what this is going to want to look like. Not only what it's going to look like, but also what would be the effects of a technology cycle like cycle 832. So if I jump into my part program, I happen to already have that posted out, just save a little time. Here we got our cycle. Now, first thing I'm going to do is I'm going to drop this to a roughing cycle, set it to a 4th tolerance. That's what we were using in the CAM system. And I can jump over and we can run it. Now, when I start to evaluate things, if I want to look at maybe something a little bit closer from like a surface geometry scenario, I may not want the whole machine space running. I can certainly have it here, so I can turn it on and start to run this part. What's nice is we add details, so I can turn off different components. So here you see I have the enclosure gone, but the tool changer and the frame is there. I can actually even shut off and just show the head and the table. So that's all customizable when the machine gets built. But what you can also do is you can still look at it back here in just a 3D view. And this view I kind of like a lot. One, I don't see the part moving around all over the place. If I've already kind of evaluated my work holding, I don't need to see that. Two, it's I got less in my way, so I can kind of move it in. Now, as it finishes, you got to give it a few seconds to refresh. And if you reorient the part, it is going to have to refresh to get its high-res image. But I start to look at it, and I can start to see all of these anomalies inside of my toolpath. So I took a couple screenshots here we're going to bounce over to kind of show you what it looks like. So obviously the part on the left, that would have been what the surface image would have looked like coming out of the CAM system on their projected idea of what the surface path would look like. You can start to see over the big radius, I have some flats there. What's happening is a CAM system creates what's called polyhedrons, right? They're little grids of flat surfaces over any curved geometries, because then it's going to take that and it's going to output these linearized toolpath over the flats. A function like Cyclea 32 is then taking those points and creating a curved arc. So I'll start to see that kind of that faceting starts to go away, but I also see in a really rough strategy that I start to get some anomalies into my part. So then I went and I did the exact same part with high speed engaged, or I'm sorry, with a finishing strategy engaged. That's the one on the far right. And you can see how much better the surface quality became. Now that's the exact same toolpath. I did not post out anything different. But really the thing I'm trying to show here is that although I would say Sinutrain was not necessarily designed to get in there and do surface geometry analysis, you can even start to see that kind of quality. If you get really close, so comparing the finished pass on the right to the pass or the representation coming out of my third-party simulation, you could even start to see where the polyhedrons were showing up, obviously from the CAM side, but I don't see that over in the Sinutrain side or the digital twin side. Now, I can also start to compare different types of cycles within the control. So in this case, I took the same toolpath. I applied top surface as opposed to advanced surface. So top surface is just a newer form of our high-speed algorithm. And there you can see, when you look at the image on the right, we did have some anomalies, some overcutting or gouging that was happening in the surface that would directly affect my surface quality that I don't see on the one on the left. And generally that's always a case where the point distribution cloud of the toolpath coming out of the CAM system wasn't consistent. So then as we were going back and forth, because I did do a bidirectional toolpath cut, I got scenarios where the calculated or computed spline could have caused an overcut or undercut scenario. So here again, just showing that we can start to look at a lot of the details that I would normally have to do during first article down on the floor. I can start to look at them right here on my PC. Okay, so the next question would be kind of where do I go from here if this is something that interests you? Now you noticed I had a website address right there for you on the screen, the usa.siemens.com/DTS. I'm going to just jump to that site. So this is our landing page that starts to talk about, here you can see the web address a little bit, that'll be the direct website address to come in. This starts to talk about Sinutrain as our digital twin. And what it also talks about is a service we're now providing to basically partner with OEMs and importers and dealers to build these custom machines for our end users. Now, typically we like to go through the OEMs or the importers because obviously if I'm going to build this high-res model, I'm going to need all of the physical models of the machine. And generally, most of the time as an end user, you don't have them. But whether you're an end user, dealer, importer, doesn't matter. If you're interested in this type of functionality, you think it might be good for your customers or for your business, come down, plug in your information, just let us know who you are. So you're an end user or you're a dealer, importer, and that should say OEM as well. We'll make sure we add that to it. Just fill this in. This will send this over to us internally, and then from there we will certainly reach out to you and help facilitate and see if we can't be able to get you guys to start using Sinutrain as your digital twin. So with that being said, looks like I'm right on the half hour. That was pretty good. So certainly if you guys have any questions moving forward, anything you need to talk about, always reach out to me. But with that being said, I just want to thank everybody for coming to our event. I certainly appreciate it, and I want everybody to stay safe and healthy, and I look forward to seeing you real soon. So with that being said, have a great evening. Bye-bye.